Okay, so 6.1, we're doing roots and radical expressions. And basically it starts off with this. We're going to do the nth root. Now, when you have this number on the outside, that's the root or the index. They'll kind of flip back and forth with what they call that. Technically that's the index, but most of the time you're going to hear they kind of flip back and forth between root or index. So either one of those two is fine. The number that's on the inside, that's called the radicand. So when you're going through a lot of these problems, you're going to hear them talk about that this would be an nth root radicand. So the root's always what's on the outside here. It's your power on the outside, or the root, the index. Whatever you have on the inside, that's the radicand. So they're going to say it's a second root number, or it's a fifth root, whatever it's going to be. So that's kind of just the basic setup when they talk about the definitions on this thing. Alright, now in some of this, again, you've already know how to do some of this. There's just a couple of details we're going to go back in and straighten up just a little bit. When you're going through these, here's what we're kind of looking at. You want to simplify the radicand as much as possible. And when we're doing these, you want to write these in factored form. Okay, best case situation, in the ideal situation, you're going to have, if this is the nth root out here, you're going to have some number, just call it b, because b for the base. You want it so that this index on the outside matches this power on the inside. And if those two things match up, then basically, when we're solving before with square roots, if we had, x squared equals 49, we were solving this. To get this down from x squared down to the number, we took the square root of both sides. And that technically this was the second root. When we did this, if this was the second root and that was the second power, we said when we did this, this would cancel and we would have just wound up with x equals 7 or x equals negative 7. So if we can rewrite these problems so that this index and this power are the same thing, the answer would be just b. Whatever that number is, or whatever that variable is that you have, they're going to cancel each other out. So that the nth power cancels the nth root. Okay, so that's the best case situation that we're looking at. That if we can rewrite these problems, we're going to rewrite it so that whatever this index is that's on the outside, we can take this number we have on the inside and rewrite it so that these two things would match up. Okay, now there's one more thing we're going to do, but before we do that, let's just do a couple examples. And on the homework, when we're going through these, there's two different types of things we have to watch out for. One thing is going to ask you to list all the roots, or list every root, or something like that. It's going to basically tell you, it's going to tell you to list all the different possible answers, so that you're going to have to kind of do a little extra work with this thing. And what you're getting on these, if you have where it says list all roots, this is where we're going back to the part that we did when we were solving with square roots, that if we had, for this problem, kind of on the side here, that if we had x squared equals 25, we would square root both sides, and we would have x would equal plus or minus 5. Okay, this one's basically saying the same thing. If you have the square root of 25, it could be 5, but it also could be negative 5. So when we're doing this one, they're still wanting the same thing. When it says list all roots, they want the positive and they want the negative roots on these if you're going through this part. And again, they're basically going back to the solving equations when we had it set up for that thing. So that's when it says list all roots, you want positive and negative. It could also start you off with, here's the first one where you have to actually kind of work with a little bit. The fourth root of 16. You know, if the fourth root of 16 is not rattling around in your head about exactly what that is, here's where you take the 16 and break it down. So you got 2 times 8, 2 times 4, 4b, 2 times 2. So if we check it, we've got 1, 2, 3, 4. We've got the fourth root of 2 to the fourth. And again, if you've got the fourth root of 2 to the fourth, if these are the same, they'll just knock each other out. And the answer should just be 4. And again, they're going to ask you to write all the answers, so you would say it's 4. And it's also going to be, wait, sorry, not 4. 2. Looking at the root there. 2 or negative 2. Because if you did negative 2 to the fourth power, that would also be 16 if you did 2 to the fourth power. So basically, it's again where you can get 2 answers off this thing. If it says list all the roots, and the only time you won't get 2 answers is if it's an odd index. Let's say it's the third root of 8. And again, if we took 8 and broke it down real quick, it'd be 2 to the third power. So we'll kind of save that step a little bit. So that would be 2. Now, and again, here's why you would not put the plus or minus on this one. Because up here, we could do 5 times 5 and get 25. You could do negative 5 times negative 5 and get 25. Same thing with 2. You could do 2 times 2 times 2 4 times and get 16. If you do negative 2 4 times, multiply by itself, you get 16. But this one's not going to be negative 2, because what happens if you did negative 2 to the third power? What answer would you get if you did negative 2 to the third power? You get negative 8, right, instead of positive 8. So this answer needs to be a positive 8. The only way you can get positive 8 is to have just the 2. So it's not negative 2. So we've got to take that part out. So on these, when you're going through the problems here where it says to list all the roots, if you have an even index, you use the plus or minus. If it's the odd index, you don't. So if it's even index, if it says list all the roots, you get to use a plus or minus. If it's an odd index, you only use one answer when you're going through this. So, you know, on the flip side, if this answer had been, you know, if we did like a D part here real quick. Is that a what? Use plus or minus. Like up here when we had the positive and negative for that part. Yeah, so even index, you're going to use the plus or the minus. If it's the odd index, you're only going to have one answer. And that's going to depend on what the problem was. You know, so if we could do like a part D on the bottom of it real quick. If that had been the third root of negative 8, if you'd taken negative 8 and broken it down, that would have gotten you a negative 2 to the third power, which would have gotten you a negative 2. So if it's an odd index, basically if it starts off positive, the answer is going to be positive. If it starts off negative, the answer is going to be negative. So that one is just going to be a one answer kind of thing. But even if it says list all the possible roots, if it's an even index, you can use the plus and the minus. You use both of them. Okay, so if it says list all the roots, that's what we're looking at doing. Is just give me the plus or minus, because again, it basically goes back to the solving part we were doing back in chapter, the last chapter we were doing where we were solving with x squared. We square rooted to cancel it off. This one's that same thing. So, if we square root 25, it could be a positive or negative 5. So if it's an odd index, it's only one answer. If it's even index, you're going to list both answers. Okay, now here's the one thing that we have to look at in chapter 6. And we're only going to do this in section 1. So it's going to be one of those things that between the homework tonight and tomorrow, we need to kind of knock section 1 out of the way by tomorrow. So it may be one of those things where if you can do 10 or 15 minutes of homework tonight with 6.1, I'll give you another 10 or 15 minutes tomorrow when we first come in. We're going to try to get 6.1 out of the way, because after we get through 6.1, we never have to worry about this one detail. And it's not a huge detail. It's just enough that sometimes it'll kind of pop up and throw people off just a little bit. So here's the one little detail that you've got to be careful of. If the index or the root, whichever way you want to call it there, is even, you must put an absolute value around your answer. Now, if it was that easy, it would be okay. The part is that you have to kind of work on and figure out. Is they say, all right, after you do this, then you have to determine if the absolute value is needed. Because in the answer, when you're going through these, and we're checking these with the online homework, if you need the absolute value in there and you don't put it, they're going to count it wrong. If you put the absolute value in there and you don't need it, they'll count it wrong. If you do need it and you don't put it, they're going to count it wrong. So it's one of those things where they're going to be kind of picky about it. Now, again, the good thing is it's only in this first section, and this is only when it asks you to simplify. So there's basically two sets of directions in the homework. The one part where it's going to tell you to list all the roots like the earlier problem that we had. And then there's going to be another part where it's going to tell you to simplify. And they may tell you, and sometimes in those they may even give you the hint of to use the absolute value and determine if it's needed. But if it says simplify, you've got to kind of keep that thought going in the back of your head. Now, when you're doing this, here's kind of one big thing that you want to have. Here's kind of the big thing that we're looking at. You need the absolute value symbols around the answer that has, what I say, x to an odd power. Again, that's one little detail that it's great if you get it, but once we get past section 1, they kind of say, all right, well, hopefully you've gotten this by now. If you haven't gotten it, then we're just going to go on with it, because it's not a huge detail, but it's just one of those little details that sometimes you need it sometimes. Okay, now, the key thing on that one is you only need that if your index is even. If that's the third power or the fifth power or something like that, you don't have to worry about this one. It's only for square roots, it's only for fourth roots, it's only for sixth roots. We're not going to do eighth roots and 10th roots, that thing. So we'll pretty much stop around sixth root. Most of the time, fourth root's about as far as we go. They'll throw in a few fifth roots every now and again, but they're not going to get too high on these. Okay, so this is the thing you're only looking out for only if it's an even root. If it's an odd root, you don't have to worry about this thing at all. So that's kind of the other thing that you want to kind of keep floating around in the back of your head there. Okay, so what we're going to do is, the rest of the problems that we're going to do from here on out, we're going to ask you just to simplify. So it says list all the roots. It's kind of that same thing. If it's even root, we'll do plus or minus. If it's an odd root, then we're only going to have one answer. And then again, if it starts positive, you give me the positive answer. If it starts negative, you can give me the negative answer. Alright, and some of these first ones you may look at this and go, well, that's easy. I don't even have to do this thing. But we'll be okay, because we're kind of building up to the harder ones that we're looking at. Alright, if you have the fifth root of 0. And what you've got to kind of think on these, or you could even rewrite it if you want to in some cases, depending on the numbers here, is you've got to get this so that we can make this power match with this root. What happens if you multiply 0 5 times? So 0, right? Doesn't really change anything, right? So for this one, we could think that if we're doing the square root of 0, that's really 0 to the fifth power. And that way, these two things would kind of knock each other out, and then the answer would be just 0. Again, that's what we're trying to do. We're trying to get this power and this index. We're trying to get these two things the same. If we do that, then we're left with just this number. And you may be going, well, that's easy because that's 0. Well, we can do the same thing with 1, right? If we did the fifth root of negative 1. You know, if we do 1 times 1 times 1 times 1, that's still going to be the same thing. So for this one, that negative 1 that's there, if we do negative 1 times itself 5 times, we're still going to get negative 1 back. But again, the whole purpose of doing that is so hopefully now we can cancel these two powers and the index out. And the answer would be just negative 1. Alright, so here's the very first one where you actually have to kind of think about it and break it down a little bit. So we're going to do fifth root of 32. So here's where we're going to go back to those directions and take the 32 and break it down. 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So we take the 32 and break it down. 1, 2, 3, 4, 5. So that's really the same thing as 32 is the same thing as 2 to the fifth. So there we go. So we can rewrite it as 2 to the fifth power. And again, these were just kind of setup questions. That if we can take this number and rewrite it so it's that number to that power, the fifth index and the fifth power knock each other out. The answer is going to be just 2. Okay, now that's more of the problems that you're going to see. That's more of the thought process we're going to have to go through. Because these, again, were just kind of setup questions to make you think about it and how we can do that. So we're going to use 32 as really that's more the example of the things we're looking at. All right, and while we're doing that one, let me show you one more here. It's the same kind of question. We're just going to change it to negative 32. All right, we know that if we took 32 and broke it down, it'd be 2 to the fifth power. But since it's negative 2, what happens if you did a negative 2 times itself 5 times? Now, we know the number's going to be 32, but what happens if you multiply negative by itself 5 times? Because negative times a negative is a positive. One more negative makes it negative. One more is positive. The fifth one makes it a negative. So that's going to be a negative 32. So for that one, we would just make it negative 2 to the fifth power. And again, the fifth root, fifth power cancel each other out. So that would be a negative 2. So if there's any good thing about the odd indexes, you basically break the numbers down. If it starts positive, the answer is positive. If it starts negative, the answer is negative. So the odd indexes are actually a little bit easier because whatever you start with, that's the way the answer is going to be.
So the main thing you're doing here is factoring?
Yes, very much so. Okay. All right, if we square root 4. Now again, that's the number we know, right? Square root of 4 is 2. But if we were going back to this one, and here's where we have to kind of clarify. If we were back here, if we were square root 4 and it listed all roots, we did positive 2 and negative 2. So here's how they kind of get around this one. Let's say, all right, well, here's where we're going to use the absolute value. And this is more just kind of to let you see what's going on. So if we had square root of 4, we could rewrite it as the second, because again, if there's not an index here that's always understood to be 2. 4, we can make it 2 squared. So that way this power, this index knock each other out. So the answer would be 2. Now here's how they kind of put this together. If we go back to the earlier problem where it said to list all the roots, how we had 2 answers. Well, the other answer we had for this thing would, okay, so if we had done the square root of negative 2 squared, that would also be negative 2. So we get to this point where we've got 2 answers. So here's what they kind of do. Here's where they were using the absolute value. So if we're doing, as long as this index is here, if we did the absolute value, what's the absolute value of 2? It's 2, right? What's the absolute value of negative 2? Still 2, right? So here's where they kind of do this. Here's where they get around this one. They're saying, all right, if whatever the answer is, if you take the absolute value of it, we can agree on that there's one answer. So if somebody says the answer is 2, somebody else says the answer is negative 2. So to fix that, we're going to say, all right, just so we don't have this argument, we're going to take the absolute value of the answer and then tell me what that answer is going to be. And that way now we can say either answer we go, which way you go with it, we're going to absolute value at the end so we can agree on one answer. And that's kind of what the simplifying says, is we want one answer, not multiple answers when we're going through these. Okay, so same thing if we had done, square root of 9. We could be 3 or negative 3, but for now what we're going to do is we're going to say, all right, whether your answer was 3 or whether your answer was negative 3, if we absolute value that, the answer is going to be just 3. So that's kind of where we're going in this section. That's where they're kind of throwing that absolute value thing out there. All right, now just that same thing, but just a little bit spin on, because we're actually going to come back and talk about this part of it here in just a second. That if we were doing the square root of x squared, again, technically, if there's not anything out here for this index, we always put it 2 because it's understood that it's square root. Those two things would cancel each other out and get x. But again, for what we're doing right now is that if that's the answer we have, all right. All right, so here we go. Here's another one. Hopefully this will kind of get us going on that same thing here. We've got the 6th root of negative 4 to the 6th power. Again, your 6th root and your 6th power are going to cancel each other out. So it's going to leave you with negative 4. Here's the only thing is, when you do this, if that's an even power out here, or even index, you have to put the absolute value around that answer. So even though the answer is negative 4, we got to take the absolute value of negative 4, which means the answer should just be 4. All right, give me a few more of those, and then we've got one last thing with the variables we've got to talk about. Okay, so if we do the square root of negative 5 squared, again, technically that is a second root that's out here. So that square here will cancel that root of 2. They'll cancel and give you negative 5. But again, because that's an even index, you have to put the absolute value around it. So the answer would be 5. Again, that's not a big detail, but it's just one of those details. They set it up in section 1. Once we get through section 1, we don't have to worry about the absolute value part of it. So it's one of those we just kind of get through that one. Now here's the one thing to be careful of. Square root of negative 49. Alright, now flashback to, I don't think it was the last test. I think maybe it's 2 tests ago. If we took the square root of 49, that'd be 7, right? What happened to the answer when we put a negative on the inside? There we go. Had to add the I variable, correct? So for this one, all they want right now is real number solutions. So if you have a square root of a negative number, just tell me that that is no solution. I know we can make it imaginary, but for what we're doing in this section is we only want real number answers. So when we're going through this part of it, even though it's square root of negative 49, we make it an I solution. We don't want the imaginary stuff. We want just the real number answers. So for this one, we'll say it's no solution. So it doesn't matter what the negative number is. If it's square root of negative of any number, just go ahead and tell me it's no solution. There's no work to do that. Alright, you have square root of 36 over 121. Just do those like 2 separate problems, because the square root of 36 is 6. Square root of 121 is 11. Now, and you may be saying, well, why don't we do it? And here's where, again, where you can kind of do this. That technically we're supposed to put the absolute value around the 6 over 11. But what is the absolute value of 6? It's going to be 6, right? What's the absolute value of 11? So just 11. So if we put the absolute value here, it doesn't change the answer. So if it doesn't change the answer, we don't have to put the absolute value. Technically, we are supposed to put them, but it doesn't change the answer, so you don't have to put the absolute value there. So that's the one part where when it talks about you have to figure out whether you need those absolute values, that's when you kind of have to do that, because technically we need the absolute values, but if we do that, it didn't change the answer we had anyway. Alright, here's a question where it's, you can kind of think your way through it, but this honestly is one of those where you can use your calculator. If you do the square root of 0.09 on your calculator, it comes out to be 0.3. So if it's a decimal number, I would say just use your calculator and it's going to come out to be just a regular number. Again, basically here's what it is. You do the square root of the number 9, which would make it 3. Every how many decimal places you have here, you have to cut that in half. So if we have 2 decimal places here, you need 1 decimal place here. Alright, a couple more of these and then we've got to look at the variables. And the variables, they won't take us about 5 minutes to go through those. Third root of negative 27. Again, we'll take the negative 27 and break it down. Or, now again, you can think about it. If we know this is third root of negative 27, the answer is going to be negative, so then we can worry about just taking the 27 and breaking it down. 27 is 3 times 9. 9 is 3 times 3. So that's the third root of negative 3 to the third power. And again, if you want to do negative 27, that would be negative 3 times 9. 9, you can make it negative 3 times negative 3. So if we've got the third root of negative 3 to the third, those 3 cancel, so the answer would be just a negative 3. And again, the good news is if that's an odd index, you do not have to worry about putting in the absolute values. You can just leave it that way. All right, let's give you one with a big number here. So let's do the fourth root of 625. Alright, we'll do over here on the side. 625, you start to break it down. Ends in 5, so you can do 5 times 125. 125 would be 5 times 25. And of course 25 is 5 times 5. So if we take the 5s and break them down, have 5 to the 4th power. Again, the 4th power, 4th index, those two things cancel each other out.